Welcome back. Now that we have successfully manipulated the canvas, we can draw on it and we can control it with the keyboard. Now it's time to control it with the mouse. In fact, virtually any user interface of any value does interact with the mouse. Now we need to be able to figure out how that works. Once again, we're not going to change our index.html. There's nothing in there that we need to update, but we are going to modify our canvas code. We've updated canvas to add an event listener for mouse movements. Every time the mouse is moved, no matter where it is within our canvas, it will call the handle mouse event function. Down here in handle mouse event, you can see what it does. It says set x equal to the offset of the mouse from the upper left-hand corner of our canvas. This is basically the XY location of our mouse on the canvas. And it sets Y to that value. It would clear the rectangle. We set the fill color, we set the stroke color, we draw our filled in rectangle, and then we draw our box around this. This is identical in every way to what we did with the key event, except that instead of manipulating the X and Y value by using arrows, what we're doing is we're setting the X and Y value explicitly to whatever the value of our mouse pointer is on the screen. Let's take a look at that. And now what I'm going to do is I'm just going to drag my mouse across the screen, and you can see that the rectangle is following my mouse pointer no matter where it goes. Very smooth. You may also notice that these mouse events are showing up down here in the console, and there's a ton of them. And notice also that printing things out as you go through your code slows your code down a little bit. It doesn't show that much here because there's not a lot going on. But you can open up these mouse events and you can see what's inside. Here you go. You can see some things like the Alt key being pressed as false. Bubbles. That means whether or not the event bubbles up to the next object in the DOM, what buttons are pressed on the mouse. And then down here, client X and client Y, these are the last X and Y locations of the mouse, whether or not the control key was held down. Lots and lots of information. Now, these are the values that we're interested in, offset X and Y. These two values show us the position of the mouse inside of our canvas. There's a lot of interesting information inside of these mouse events. Let's take a look at our code again, because there are some things I'd like to change. One thing I notice is that we've duplicated code here. See this bit of code here that redraws the rectangle on the screen? Exactly the same in both places. There's this concept in software engineering called don't repeat yourself. We want to create dry code, DRY. The problem is that we have the same code in two places. Now, let's suppose that we just wanted to draw the boundary, just the empty rectangle. I've reset my code, and you can see it's redrawn the square, the rectangle, just as a black border with no color inside. But when I start dragging it, the color returns, and that's probably not what I really meant. What we can do, of course, is we go into the other method and fix that as well. And then when we go back, now it's working as expected. The problem we're having here, and this is a common problem in software engineering, is that we've written the exact same piece of code in two different places. What we want to do is not repeat ourselves. We want to keep our code dry. And to do that, what we're going to do is we're going to add a method called redraw. Then we're going to grab our common code. This is what's called refactoring. We're not really changing the way the program works. All we're doing is moving the logic around so that it works better, right? It's easier to maintain. In fact, instead of calling handle key event here, I'm just going to call it redraw. Okay. Let's restart our program. There's our rectangle. But strangely, it stopped working. And the reason it stopped working, of course, is that I have a bug. Although I refactored my code and put redraw in its own function, I neglected to call it at the bottom of each event. Let's do that right now. This method of moving your code around to make it more maintainable, to keep it dry, so that you're not repeating yourself, is what's called refactoring. This refactoring step hasn't changed the logic of our application, but it's definitely made it more maintainable, easier to understand. So that's called keeping your code dry. Okay, welcome back. Now what we've done is we've created these two new listeners, the mouse up listener and the mouse down listener, and they call the same method. They could have called their own functions, but we've decided to put all of our mouse handling code in one place. If we take a look at this code, we are checking the event type, and this type is going to tell us whether it's a mouse up event or mouse down event. And if it's a mouse up event, we're going to turn this flag or this variable called drag to false. If it's a mouse down event, we're going to turn drag on. In other words, it's true. The effect of this is that when we click on the object, we click the mouse down, we get an event. We're now going to start dragging the object around the screen. We need a variable to let us know when that happens. The next thing that happens is that if the drag variable is on, we're going to move the square wherever the mouse pointer is, at the offset X or offset Y, just like we did before. And then we're going to call the redraw method. If we let the mouse up, drag is turned to false. And the next time we move the mouse, drag will be false. It will not move the square with it. Let's go back and take a look at that code and see how that's running. Reset. Notice now that I'm moving the cursor around and we're not getting any motion. And if we go back to this, you can see the console log. It's letting me know what buttons are being pressed and the type of the event. And you can see that we're getting a ton of mouse move events. But I want to come over here and I want to click on the square and notice that it jumped right to where the mouse pointer is. Okay. And I've still got the mouse clicked down and I'm dragging. And you can see as I move my mouse around, because the mouse was clicked down, the drag variable is still true. It's moving the square wherever the mouse pointer is. I'm going to let up on the mouse and it appears to have dropped it. So it was dragging the square around, because when I lifted up on the mouse, it set the drag variable to false. Let's go back and look at our code and look at this again. When I clicked down, the drag variable was set to true. Every mouse event that came through, every mouse move event that came through, saw that the drag was turned on. It's moving the square with the position of the mouse. And then when I let up on the mouse, it set the drag variable to false. No matter where I moved it, it wasn't going to update the position of our square. And notice also that while we're in here, I can still use my keyboard events to change the color of our square, and it still drags around. Now you may have noticed that, like, when I click my mouse, the square jumps to the mouse position, and that's not really a very pleasant user experience. In the next experiment, what we're going to do is figure out how to grab it and drag it and make it look like we grabbed it from a particular position inside the square. Okay, welcome back. If you remember from the last experiment, we had a problem where the square would jump to wherever the mouse was. But what we really want to be able to do is only have the square under mouse control if we click the mouse button inside the square itself. Okay. I didn't make any changes. Most of this code is exactly the same as before. But if you look here, when I hit the mouse down event, I check to see if the mouse offset is greater than the X coordinate of the square, and also that it's less than the X coordinate plus its width. That's important. And then also, I want to see if the Y coordinate is greater than the Y coordinate of the square, but less than the Y coordinate plus its height. If we look at what our square looks like, the X coordinate is here, and then the X plus the width is over here, and the Y plus the height is down here. And what I want is, I only want this to be active if I'm clicking inside the square. I don't want to grab it like anywhere on the screen. If I'm clicking on the background, I don't want the square to jump. I only want the square to come under mouse control when I click inside the bounds. That's what it's called, inside the bounds or boundaries of this square. That's what this code does. It checks to see if the mouse, when it was clicked down, was inside the bounds of that square. And if it is, then we're going to start dragging it. Now, the other thing I did, just a little bit of a slight change, is that I set X width and height variables for the square. If we wanted to, we could change this to 50 and we'd make a rectangle. And then down here in the redraw function, I use X, Y, width, and height. Now, when I refresh this, you can see now that it's a vertical rectangle. And also notice that now, if I click outside of the rectangle, it has no effect, right? It's not dragging it. But when I click inside, now I can drag it. And if I let up on the mouse, it drops it. This is really important. It gives the illusion that we've got an object on the screen that we're dragging around, almost like it was a physical object. But in fact, all we're doing is we're clearing the playfield, this canvas, and move the XY coordinate of that rectangle and drawing it in different places every time. And because our eye has persistence of vision, it gives the illusion that we're moving this rectangle around the screen. Now, notice also, if I click in the upper left-hand corner of this rectangle, it jumps up, and you notice that it jumped to the middle. And that's because I also made a slight change to the code when I did the drag, is that I captured not just the X offset, but I subtracted off the width over 2. This gives the effect of grabbing the rectangle from the center of it, wherever it is. And it jumps down there. And that's a little bit annoying. I'd really like this not to jump. What we're going to do next is actually compute where on the rectangle we're grabbing, and then always redrawing it that far away from the mouse pointer. So that it looks like we've grabbed it in a particular spot and we're dragging it from that spot on the rectangle. I've added a couple new variables, which I call grab dx and grab dy. But these are going to be the offset of where we grab the rectangle from. So if I'm over here and I click in the upper left-hand corner, I'm going to compute the distance from the upper left-hand corner to wherever it was that I grabbed the rectangle. And I'm going to store that value in grab dx and grab dy. It's called dx dy. It stands for difference of x, or mathematicians would call it the delta. These are the delta x and delta y. The only change I made to the code was down here, that not only do I set the drag to true, I also compute this grab dx and grab dy. I take the xy coordinate of the mouse and I subtract off the xy coordinate of the rectangle. That gives me the delta from the upper left-hand corner of the rectangle to wherever the mouse clicked on the screen. And then down here, when we're dragging, remember before what I was subtracting off was width over 2. Now I'm just going to subtract off grab dx and grab dy. What this does is it says, see, the x coordinate of the rectangle is up here. And then when we clicked on it, it was this small distance away. And now what we're going to do is we're going to draw it not where the mouse pointer is, or even at the 50% point or the midpoint of the rectangle, but we're going to go an offset from wherever it was we clicked on the rectangle. Let's give that a try. This is back to being a square. If I click near the upper left-hand corner and then start dragging, you can see that we've really completed the illusion of a physical object on the screen that we're grabbing and moving around. And because we have persistence of vision in our eyes, it looks like this is a physical object moving around under the control of our mouse, that we grab it in the upper right-hand corner and it continues to move it by pushing that upper right-hand corner around. So that pretty much concludes the whole concept of user interface input. We have the ability to change the square based on a keystroke. We can also use the mouse to move things around. We can grab things, and we have the illusion of images moving around as if they were physical objects on the screen under our control, thanks to the principles of animation and the persistence of vision in our eyes. So our next experiment will be real-time animation. While it's fun to be able to move things around and to type on the screen and see results, what's really fun is when things start moving around on their own. Tune in for that next series on real-time animation.